All right. Okay, let me set up kind of the steps that are necessary for a hypothesis test. I think you guys get maybe the overall picture and the concept. So let me.
For the formulas, are they always giving a p hat and a mean of the population of the sample?
Okay, so far the hypothesis test that we've seen, that's how it's going to be. Okay, but you will learn another type of hypothesis test later today, like within the next hour, and it gets a little bit more complicated. Okay, but this process and the concept is still the same. Okay, so what we've done so far is one sample proportion hypothesis test. Tonight I will also teach you the two-sample proportion hypothesis test. I know. And then next week you're going to learn the one-sample mean hypothesis test and two-sample mean hypothesis test. Okay, but today, it sounds like a lot of fun, right? So, but today, so far we've learned the one-sample proportion hypothesis test. Okay, our null hypothesis for the one-sample proportion hypothesis test will always be p is equal to some number, okay? So just as a placeholder, I'm going to put in the number 0.3, okay? But it's always going to be p equals, and then just put in some proportion here, okay? Some number here. The alternative is going to be p does not equal 0.3, okay? Or p is greater than 0.3, or p is less than 0.3, okay? It's either greater than, not equal to, greater than, or less than, okay? The null hypothesis will always have an equal sign, okay? And whatever number, the number that shows up over here in the null hypothesis is the same number that shows up in the alternative, okay? So a common mistake is using one number here and a different number here. Okay, don't do that. Always use whatever number you put here is the number that's going to be in the alternative. The alternative can have not equal to, greater than, or less than, depending on how the question is written. Okay. In the alternative, depending So if the question says, is this evidence that the proportion has increased or is bigger or something, you're going to use greater than, okay? So if the question says, that the proportion is, okay? So if it says, bigger, or, increased, larger, etc., words like that, use the greater than sign, okay? On the other hand, if you get things like smaller, or less, whatever, use the less than. Okay, and the last one is it different, changed, or anything like that, use not equal to. Okay? So depending on how the question is written, you might use a different symbol. Greater than, less than, or not equal to. Alright? So you got to figure out your null and alternative hypothesis. Okay? Okay, and the next part is write out what your data shows. Okay. Okay, and figure out what we call alpha. And figure out or decide alpha. Okay. Alpha looks kind of like the A or a goldfish or whatever, okay? This is the point where we decide the probability is small or not, okay? Because our decision is, if the probability of observing our data is small, we're going to say, we can conclude that the coin is unfair or something, okay? But if the probability is not small, we can't reject the null hypothesis, okay? So the alpha is the point where we decide if something is smaller. Okay. The most common choice for alpha is 5%. Okay. So alpha is most commonly 0.05. Alright. But some people might choose alpha to be 10%, some people choose alpha 1%. Okay? It'll often be given in the problem. If not, assume 5%. It's just like you drive down the highway. Sometimes they'll post different speed limits. Let's say speed limit 55 or speed limit 70. Okay? But most commonly it's 65. And if you're driving down some stretch and you have no idea what it is, just assume 65. Unless it's a 2-lane highway, then 55, right? So that's kind of how it is for alpha. Okay? It's most commonly 5%. Sometimes it's something different. If it doesn't say, just assume 5%. Okay? Then the next step is to figure out your p-value. This is all the math that we've been doing, okay? P-value, okay? And here's the key definition. A p-value is the probability of observing our data or something more extreme we assumed that the null hypothesis were true. If we assumed that the probability that the coin lands heads is 0.5, what's the probability that I flip a coin 500 times and get 400 heads? The answer to that question, that probability, is the p-value. If I assumed that the proportion of people who liked my product after watching the commercials is still 20%, what's the probability that I take a sample of 200 people and observe 23% liking the product? The answer to that question, that probability, is the p-value, okay? So I erased it, but so if you look at your notes, so in the previous example, our p-value was 0.1446, okay? In our previous problem, the p-value was 0.1446. It's just giving a name to that probability that you calculate. Okay, so this is where a lot of the math goes. Yes?
Is that supposed to say for or?
The probability of observing our data or something more extreme. Yeah, or something more extreme. Okay? And then so lastly, make your conclusion. And the conclusion goes like this. If the p-value is greater than alpha, okay, so alpha is that point where we decide if the p-value is larger or not. If the p-value is greater than alpha, that means we do not have evidence to reject the null. If the p-value is less than alpha, we say we have evidence to reject the null. Yes?
Is this chapter 8?
Yeah, this is chapter 8.
Okay.
Okay. So I'm trying to balance the time that we have in our class here. Okay. So I'm going to, what I'm going to do is I'm going to present to you the two-sample proportion hypothesis test now, okay? No, let me just finish out the one-sample proportion hypothesis test, okay? But I think you guys already know how to do the math portion for the one-sample proportion hypothesis test, okay? I think you guys already know how to do that, but I'll just put it up on the board so we can draw some parallels here, okay? So the math part, right? So let's say P, let's say H0 shows that P is equal to 0.3, okay? And then our data is N is equal to 100 and P hat is equal to 0.40, okay? So then what we do is we draw a null hypothesis at normal distribution with a mean at 0.30, and then we ask what is the probability that I get 0.40 or something more extreme. Okay? So I have to figure out my standard error, which is going to be 0.3 times 1 minus 0.3 over 100, and I take the square root. And then my z-score is equal to 0.40 minus 0.3 over standard error. Okay, I look up the z-score in the z-table and figure out the area. Z-table to figure out the area. And I think we're at least familiar with this process, right? You guys already had a quiz on it, and I feel like we've done it enough times. I hope, all right? So now you just have to do it in the framework of the hypothesis test. And so based on that, then we make a conclusion or something. All right. Let's now go to the two-sample proportion hypothesis test. Now all of this, it feels a little bit, the first time you're exposed to something, it always feels overwhelming. But you're going to be exposed to it early, and then you'll become comfortable with it over time. So by the final exam, you'll all be A+. Okay. We hope. All right, so two-sample proportion hypothesis test. Contrast what happened with the one sample proportion and the two sample proportion. So the one sample proportion, my data was one sample, and I'm comparing the proportion from my sample, my p-hat, I'm comparing it to some established proportion already. So in my data I said the established proportion, so one of the examples was the established proportion was that 20% of people liked my product. And I'm comparing what I got in my data, where 23% of my sample liked the product. I'm comparing that 23% to this established proportion of 20%. With a two-sample proportion test, I no longer have an established proportion. Instead, I have two samples. And I'm going to compare the proportion of one sample to the proportion of the other sample. Okay? So in the one sample proportion, we had an established proportion. With the two sample, no proportion established, I just have two samples, and I'm comparing the samples against each other. So there is no established proportion. Okay. Instead, we have two samples. Process and the way of thinking for a two-sample proportion test is the same as it is for a one-sample proportion test. Okay, the thought process is the same. The things that change up are the way you calculate the standard error and some of the formulas and stuff. Some of those things change, but the same thought process applies. meaning, you know, here's the data I observed. If I assume the null hypothesis were true, what's the probability that I would get my data or something more extreme? And then we use that. Okay, so if we have two samples, okay, so our data consists of two samples. Sample 1, where I get n1, which is the size of sample 1, okay, and p hat 1, which is the proportion from sample 1, okay? And sometimes we have to figure out p hat 1 by doing, you know, let's say I said there's 100 people in sample 1 and 30 of them, you know, like the product. There, your sample proportion would be 30 over 100.3. Okay. Sometimes you gotta calculate that. And over here we have sample 2. And so we have n2, oops, and p hat 2. Okay, to distinguish the n and the p hat from sample 1 and from sample 2. And the question is, you know, let's say, okay, so now I have two versions of a commercial, right? I went to this advertising agency and I said, make me a commercial. And I go to another advertising agency and I say, make me a commercial, okay? And they come back and they give me two different commercials. And I say, okay, well, now I want to know which commercial is better, right? I'm going to air it on the Super Bowl and I can only afford to buy one spot. So I got to pick the better one, right? So I show commercial 1 to 200 people. I show it to 200 people, and you know, let's say 33% liked it in commercial 1. Okay, and then I show commercial 2, and after commercial 2, let's say 35% liked it. Okay, so I got 33% versus 35%. Does that mean commercial 2 is definitely better than commercial 1? No, maybe, maybe not, okay? So we would have to do a hypothesis test to see if the commercials truly are different or not, okay? And that's how we're going to do sample 1 and sample 2, okay? So here, the null hypothesis for a two-proportion sample test is always, okay? And is always going to be P1, the proportion from the population. Okay, so notice there's no hats. That P1 minus P2, but the difference between them is 0. Okay? No hats. There's never hats in the hypotheses. Okay? Okay, or equivalently, okay, this is the same as writing P1 is equal to P2. So we can either say that the difference between the proportions is 0, or that there's no difference, and that's the same thing as saying they are equal to one another, right? And then the alternative can be P1 minus P2 doesn't equal 0, that's probably the most common, or we can do is greater than 0, or is less than 0, okay? And again, this depends on how the question is written. Okay. And notice there's never any hats. In the hypotheses. Always P. Okay, so for a two-sample proportion test, two-sample proportion when we do this, we're going to set up a normal distribution, okay? And the mean, what do you think the mean of the normal distribution is going to be? It's going to be 0. Whatever we write in our null hypothesis, that's the number that we're going to use for our mean. Okay? So we put a 0. So the mean is equal to 0. That's what we're expecting.
So what did that say, two-sample proportion HT?
Hypothesis test.
Oh, okay.
Hypothesis test. So the mean is going to be 0. And the value that I put here, okay, so just like finding where I'm located, this value is going to be the observed difference, okay? My observed difference how do I find my observed difference using my data? I'm going to take P1 hat minus P2 hat. So my observed difference is equal P1 hat minus P2 hat. So if I say I showed commercial 1 to 200 people and 33% liked it over here, and I showed commercial 2 to 200 people and 35% liked it, what's my observed difference? 2%, right? 33% versus 35%, I have a difference of 2%, 0.02 is my observed difference. And I want to know, is that 2% difference, is that significantly different from a difference of 0? Yes, question?
Wasn't P hat 1 of 0.33?
Yeah?
And then P hat 2, wouldn't that be a negative difference?
Yeah, 0.35? Yeah. So, we'll talk about that. Yeah, so I would get a difference of negative 0.02. Yes.
Okay.
Doug?
I apologize if I'm asking the obvious, but you just stated there's never any hats, and then you're back to the P hat. Is that because it's,
Never any hats in the hypotheses.
okay?
In the
and
hypotheses.
This is the hypothesis test, right?
Uh-huh. Uh-huh. So this is the hypothesis here, okay? So when I'm writing these things, when I'm writing out the hypotheses, I never put any hats there,
I understand.
okay? But then when I do the problem, I've got to use hats, okay? I've got to distinguish, because this is about the population, okay? Because if I said I showed 200 people commercial 1 and 33% liked it, and 200 people were shown commercial 2 and 35% liked it, there's no question, did more people in my samples, did more people like commercial 1 or commercial 2? The answer is commercial 2 did a better job in my samples, okay? But I looked at a total of 400 people, okay? But that's not the question I'm going for. I want to know what's going to happen when I play it on the Super Bowl, okay? And this is the population where everybody's going to see it, okay? And so I'm not curious, was there a difference when I showed it in my samples? Yeah, there was. The question is there going to be a difference when I show it to the nation? Okay? And that's why we use P to distinguish, to indicate that we're talking about the nation here and not just my samples. But what I'm talking about over here is the data. I don't have any data from the nation yet, okay? All I have is data from my samples, so I have to use my p-hats. Okay, so here my observed difference is this. Alright. And my standard error, okay, and you just got to bear with me, because the standard error is this ugly formula, and we can't do anything about it, okay? There's, is p hat times 1 minus p hat just this ugly formula. We can't do anything about it. That's what we get. Alright? And that's our standard error. Okay, and we'll talk about this in a little bit more detail here. Okay? because there's a few steps. Okay, so if I wanted to find a z-score, what do you think my z-score would be? My z-score is always what I observed minus what I expected divided by the standard error, right? So what did I observe?
0.02.
Yeah, well, I'm going to put p1 hat minus p2 hat. Okay. And what was I expecting? A difference of 0. And my standard error is this crazy thing. So I'm going to get a z-score this way. Okay. And now once I have a z-score, what do? I look it up in the z-table or z-chart, and then I figure out the areas that I'm looking for, right? Area in the tail.
Is that -0?
Yeah, it's a -0. Okay? So a lot of times you'll just see this ignored because -0 basically does nothing, right? So sometimes you'll just see p1 hat minus p2 hat divided by the standard error.
Wait,
Yes.
oh, we're always expecting 0?
For a two-sample proportion hypothesis
Oh.
test, we're expecting a difference of 0
okay.
if the null hypothesis were true. Because the null hypothesis says that there's no difference between these. So if there's no difference between what happened with commercial 1 and what happened with commercial 2, anytime I show the two commercials, if commercial 1 and commercial 2 were the same commercial, right? Anytime I show them to same groups, I would expect the same proportion in sample 1 as same proportion in sample 2. But just because people are different, that might not be the case, even if I showed them the exact same commercial. Alright, so let's try going through an entire thing. Oh, actually, there's one more thing I have to talk about. So the standard error is actually even uglier than what it appears here. Okay? Because the thing is what's p hat? Well, you don't know that, right? Because all we have is p1 hat and p2 hat. Did I ever tell you how to get p hat itself? No. Okay. Now for a two-sample test. So p hat for this, okay, and it only applies to the two-sample proportion hypothesis test. P hat is the overall proportion, okay, overall proportion from the data. Okay, this is equal to the number of successes in group 1 plus the number of successes in group 2 divided by n1 plus n2. Okay, so let's try a two-sample proportion hypothesis test for this commercial thing that I'm making up. Okay, so I have two commercials. Two commercials are available. I want to know if there's a difference between them. Okay, is there a difference between the performance? Okay, so I'm going to do group 1. Group 1 was shown commercial 1. N1, so I'm going to just change up the numbers a little bit differently. So let's say 150 people were shown commercial 1. And let's say 45 people like the product or will buy the product. Okay. Group 2. showed the commercial to 200 people, and let's say 66 will buy the product. Okay? So from this, what's my P1 hat and what's my P2 hat? Yeah, no. P1 hat is going to be 45 divided by 150, right? So P1, anytime you're talking about proportion, it can never be a number bigger than 1. It always has to be between 0 and 1. It's always a proportion. So I do 45 divided by 150, and I get 0.3. And P2 hat, I do 66 divided by 200, and I get 0.33. So 30% after commercial 1, 30% said they're going to buy the product. I showed 200 other people commercial 2, and after that 33% said they're going to buy the product. Okay, so I'm observing a difference of 3% in the performance of the commercials. So does that mean commercial 2 is definitely better? Maybe, maybe not. We got to do a hypothesis test. Okay, so I'm observing a difference of 3%, or if I want to frame it the way the test is written, my observed difference is equal to P1 hat minus P2 hat. So I have 0.30 minus 0.33. I have a difference of negative 0.03, okay? Meaning commercial 1 has a 3 percentage point difference in that they're 3 percentage points behind commercial 2 in terms of people who like the product. The question is that difference significant or not? Well, let's do our math. Okay? So part of this, I've got to figure out my P hat. So the P hat is the overall proportion, and this is overall, what is the proportion of people who like the product? Do we know? Overall, how many people like the product? 45 plus 66. And how many people total saw the commercials? Yeah, 150 plus 200. So overall, a total of 350 people saw the commercials, and a total of 111 people saw said they liked the product. So my overall proportion is 0.3171. Okay, so overall, 0.3171 like the product. Okay, so my null hypothesis, what is my null hypothesis? My null hypothesis is that the difference between the proportions of people who like the product after commercial 1 and commercial 2, that there's no difference between them. My alternative is that there is a difference, okay? So if the null hypothesis were true, anytime I show the commercials to groups, what kind of difference would I expect between the two groups? Now, I would expect a difference between the groups of 0. I would expect the groups to be the same. I would expect no difference to exist between the two groups. Overall, the proportion would be 0.3171, okay? But overall, I would expect no difference between the groups. What was the difference that I observed? Negative 0.03. I saw a difference where commercial 1 was 3 percentage points less than commercial 2. So I want to know what's the probability of getting a 3 percentage point difference or something more extreme. Okay? Because I have a not equal to sign here, okay, I would be interested if commercial 1 did worse or if commercial 2 did worse. Okay? So I'd be interested in both a 3% negative and a positive 3% difference. Okay? If that's a little bit confusing right now, don't worry. Through exposure, you'll get used to this. Okay? But basically, the key here is the not equal to sign means we have something called a two-sided test. Two-sided test, okay. Alright, so I've got to figure out my z-score, which requires that I know my standard error. Okay? So my standard error is that crazy ugly formula. And so I'm going to use p hat, which is 0.3171. And I'm going to multiply it by 1 minus p hat. So 1 minus 0.3171 times 1 over n1, which is 1 over 150, plus 1 over n2, which is 1 over 200. Okay? Alright. So calculator check. See if you can do this on your calculator and get the same answer again. So if you have a fancy calculator, or I mean not even that fancy, but if you have a calculator like this, you can type it basically all in one go. And and then you just take the square root at the end. So when I'm typing literally exactly as it's written here. Just the inside 0.3171 times parentheses 1 minus 0.3171 close parentheses times 1 divide by 150 plus 1 divided by 200 close parentheses. And when I do that, I get a number, and then I hit the square root answer button, and I get 0.0503.
So that's square root.
Square root answer. Are we getting this? Okay, good.
How do you do the third part of
I'm just doing parentheses, 1 divide by 150 plus 1 divide by 200, close parentheses.
How many numbers do you like to keep when you square root?
I usually like about 4 or 5 decimals. That's about how much I go with generally.
Is it 0.565?
I'm getting 0.0503.
I don't have parentheses on this, I have brackets and.
Okay, brackets should do the trick. I'm pretty sure that calculator's got parentheses.
Well, it has, I guess maybe there's no parentheses, but
Okay. Alright, if you guys are having trouble, you can ask me later, but let's just assume you did this calculator bit and you got 0.0503. Okay? Now that we have that, what is our z-score? Yeah, so my z-score is I take my observed difference, which is negative 0.03, and I subtract off the mean, which is 0, and I divide by my standard error, which is 0.0503. So I get a z-score of negative 0.6, I don't know. .59? Yeah, no, negative 0.6. Alright, and so now I go to my z table and I look up the area to the left of negative 0.60. And the answer to that is 0.2743. Alright. And because it's a two-tailed test, I'm going to have the same amount, 0.2743, in both tails. So the total area in both tails is 0.2743 plus 0.2743. So that's 0.5486. Is this number big or small? It's big. It says that anytime I show these commercials to a group of 150 and a group of 200 people, I've got over a 50% chance of getting a difference of 3% anyway, just by random chance. So the fact that I saw a difference of 3% basically tells me nothing about which commercial truly performs better. Does that make sense? So right now I've got no evidence supporting the idea that one commercial is better than the other commercial. Or we do not have evidence showing that one commercial is better. What is this number here, 0.5486? What do we call that?
What was the question?
This is called my p-value. Okay? And if I assumed alpha is 5%, 0.05, my p-value is bigger than alpha. And that's why I do not reject the null hypothesis, and I come to the conclusion that we don't have evidence that one commercial is better than the other. Yes.
What was the word after both?
In both tails. Okay. Yes.
Besides, you don't reject it.
Yeah, we do not reject the null hypothesis. Does this mean that the two commercials perform exactly the same? No, it doesn't prove that. But right now I've got no evidence that one commercial is any better than the other. Okay. Probably just because you know, I showed it only to 200 people and 150 people. That's probably not enough for, you know, if we wanted a true market study, we need to study more than 200 people and more than 150 people. Okay, how's that? Is that rough?
It's hard like tying it all together.
Yeah, I know. It feels like a lot,
Because
okay?
it's like so many steps that by the time you get to the end, you forgot where you started.
That happens in the beginning, okay?
Yeah.
It happens in the beginning, right? Just like the first time you went driving, you probably maybe felt a little bit overwhelmed by everything that you're supposed to be doing, right? Like, yeah, every time you drive, you're supposed to like kind of check for cross traffic at the, you know, stop signs, and you check your mirrors and all of these things. In the beginning, it's probably a little overwhelming, but now it's all second nature, right? If someone comes up behind you on the highway, it's like you already know someone's behind you because you've been checking your mirror the whole time, okay, without even thinking about it. So these things become they become second nature with a little bit of practice. Okay, so let's try. We'll try one just an example. I'll let you guys do it with. We'll do a one sample proportion hypothesis test. Okay, so we just did a two sample proportion. We'll go back and do a one sample proportion hypothesis test. Okay. Alright, so we'll say someone claims that what percentage of America do you think owns a cat? A cat. A meow. Meow meow. What percentage of Americans do you think own a cat? Households?
I'll say 40.
40? Okay. Alright, someone claims that 40% of Americans own a cat. Alright. I'd say probably it's not that much, okay? So we go out and we collect data. We collect some data. Alright. We interview 400 households. And we find that 136 own a cat. Is this evidence that less than 40% of households own a cat? Alright, here are your questions, okay? 1. Write out the hypotheses. Okay. 2. What is the standard error? 3. What is the test statistic? Okay. Test statistic in this case is basically what is the z-score. What is the p-value? And 5, what is your conclusion? Alright, go ahead and try that. I'll pause the video and then when we're done, we'll go over the answers.